The second way to calculate the probability of x is greater than or equal to 4 is we take 100% minus the opposite. The opposite of x is greater than or equal to 4 is x is less than or equal to 3. So first we need to find out the probability of x is less than or equal to 3. And we're going to use the formula equal binom dot this. And then we're going to click on the f of x. First number is your x. X is 3. We're looking for the probability of x is less than or equal to 3. So our x is 3. And the trial here is 6 and a 6. And then the probability is 0.53. And then for the cumulative in this case will be true. The reason cumulative is true is because we're looking at the probability of x is less than or equal to 3. We're not looking for the probability of x is equal to 3. We're looking for the probability of x is less than or equal to 3. And that's what the cumulative stands for. When we have true for cumulative, what it stands for is that we're looking at the cumulative probability of x from the very left side all the way to the number x equals to 3. So what we're looking at is the cumulative probability from 0 all the way to x equals to 3. And that's what the cumulative stands for. It goes from the very left side all the way to the value of x. We're looking for the cumulative probability of x from the very left side, which is 0, all the way to x equals to 3. So from a diagram perspective, what that means is that when we put true for cumulative, what that means is that we're looking for the cumulative probability from x all the way from the left side. From the left side in this case is x equals to 0, all the way to the x value, which is x equals to 3. And when you put true for cumulative, it always starts from the left side all the way to the x value. In this case, x is 3. That's how Excel works. It doesn't start from the right side, it starts from the left side. It goes from the very left side all the way to the x value, x equals to 3 in this case. So that's why when we want to find out the probability to the right of a certain value, we need to take 100% minus the probability to the left of that value. So again, if you put true for cumulative, that means we're taking the cumulative probability from the very left side, which is from 0 in this case, all the way to the x value, which is x equals to 3. So that's what we're looking at. If we put true, then we're looking for the cumulative probability from 0 all the way to 3. So once we understand this concept, we put a 3 for the x, trial is 6, probability is 0.53, and then we put the true for cumulative because we're looking at the cumulative probability of x is less than or equal to 3. And then we press OK, and we're going to get the 0.5985. And then we take 100% minus that probability, so we take 1 minus the probability of x is less than or equal to 3, and then we're going to get the same answer that we had earlier, which is the 40.15%. And that's part C. So from part A, part B, and part C, what you need to know is that there are 3 scenarios. And I've illustrated in this example here. In the first scenario, we have probability of x equals to 2. In the second scenario, we have probability of x is less than or equal to 2. In the third scenario, we have the probability of x is greater than or equal to 2. So those are the 3 scenarios that you will encounter. And you need to know how they're different. So for the first scenario, we have probability of x is equal to 2. We have x equal to a specific number. So what that means is that when we use the binom dot this, we're going to use x equals to 2. So what that means is that when we put it into the binom dot this formula, we're going to put x equals to 2. And then for the cumulative, we're going to put false. The reason we're putting false is because we're looking for x equals to a specific number. For the second scenario, we have probability of x is less than or equal to 2. And again, in this case here, we're putting x equals to 2. And the only difference here is that now for our cumulative is going to be true. We're looking for the cumulative probability of x is less than or equal to 2. So if our lowest number is x equals to 0, then we're looking for the cumulative probability of x going from 0 all the way to 2. So 0, 1, and then 2. And that's what putting a true here means. We're taking the cumulative probability all the way from the left side to the x value, which is x equals to 2. That's the second scenario. The third scenario is trickier. For the third scenario, we're looking for the probability of x is greater than or equal to 2. To find out the probability of x is greater than or equal to 2, what you need to understand is that in Excel, the cumulative function in Excel only takes the probability from the very left side all the way to the x value. It doesn't take the cumulative probability from the right side to the x. The cumulative functions only takes the probability from the left side all the way to the x value. That's what you need to know in terms of how Excel works. So in order for us to find out the probability of x is greater than or equal to 2, what we need to do is take the 100% minus the opposite. The opposite of x is greater than or equal to 2 is probability of x is less than or equal to 1. So that's the opposite of x is greater than or equal to 2. So that's why we have the 100% minus the probability of x is less than or equal to 1. And that will give you the probability of x is greater than or equal to 2. So we're going to look at it from a graphical perspective. So in this diagram here, we have x, and x starts from 0 and all the way to infinite numbers. In our third scenario, what we're looking for is probability of x is greater than or equal to 2. So from a diagram perspective, what we're looking at is all the number from 2 and then to the right. So 2, 3, 4, 5, 6, 7, all the way to the right. That's what we're looking for. We're looking for the probability of x is greater than or equal to 2. And to find out that probability, what we're going to do is we're going to take the 100%. 100% is all the possible outcome minus the opposite. The opposite is basically your probability of x is less than or equal to 1. So that's the opposite. So that's why we're taking 100% minus the probability of x is less than or equal to 1. And that will give you the probability of x is greater than or equal to 2. So that's what you need to understand from this diagram here. So therefore, when we calculate the probability of x is greater than or equal to 2, we know that we need to take 100% minus the probability of x is less than or equal to 1. What that means is that when we plug it into the binom.disc formula, we're solving for the probability of x is less than or equal to 1. So therefore, when we plug into the binom.disc formula, we're going to use x equals to 1, and we're going to put true for cumulative, because we're looking for the probability of x is less than or equal to 1. So we're looking for the cumulative probability of x from the very left side all the way to x equals to 1. Once we calculate the probability, then we take the 1 minus that probability, and that's what we're going to do. And that will give you the probability of x is greater than or equal to 2. So those are the three scenarios that we have. So when you have x equals to a specific number, you put cumulative equals to false. That's the first scenario. For the second scenario, when you have x is less than or equal to a number, then you put true for cumulative. And for the third scenario, when we're looking for x is greater than or equal to 2, what you need to know is that because we're taking 100% minus the opposite, so therefore we're not taking the x equals to 2, we're taking the x equals to 1, because we're looking for the cumulative probability of the opposite side, which is the left side. So that's why we have x equals to 1. And once we have done that, we take 100% minus the probability, and that will give you the probability of x is greater than or equal to 2. So those are the three scenarios that you need to understand. And all these three scenarios come from understanding the diagram that we draw earlier. And that's part A, part B, and part C. Part D, well, the mean and standard deviation of the number of 18 to 29 years old who own a tablet in a survey of 6. So to calculate the mean, variance, and standard deviations, we're going to use the formula given in the lecture notes. So to calculate the mean, we're going to take the n times the pi. N is your 6, and then pi is your 0.53. Once we calculate that, once we times that, you're going to get the 3.18. Variance is similar. Variance is n times pi times 1 minus pi. So we have the 6 times the 0.53 times 1 minus 0.53. And then you're going to get 1.49. And that's your variance. Standard deviation is just the square root of the variance. So that's why we put equal SQRT, square root of the variance. And you're going to get the 1.22. And that's the mean and standard deviation calculations. Part E, what assumption do you need to make in part A through part C? So the assumption that we need to make are, we're assuming we have independence. We're assuming that the probability stays constant. We're assuming that the probability stays constant from observation to observations. So we have the independency, and that's for A and B. And then for D, we have the mutually exclusive and collectively exhaustive, the assumption that we have earlier. So those are the four assumptions that you need to know. Independency, mutually exclusive, collectively exhaustive, and then the probability is pi or 1 minus pi. So we have constant probability.